Guys, today I'm going to do another LeetCode Daily Challenge. Let's get into it. Today's problem 2140, solving questions with Brainpower. Which is kind of the opposite of what I've been doing recently. Haven't been using my brain. Let's go. So you are given a 0 index 2D integer array questions where there's points and Brainpower, okay? The array describes the questions of an exam where you have to process the questions in order, starting from question 0, and make a decision whether to solve or skip each question. Solving question I will earn you points I, but you will be unable to solve each of the next Brainpower questions. If you skip question I, you get to make the decision on the next question. Okay, that makes no sense to me. So you're given a bunch of points, Brainpower, all of these. If question 0 is solved, you will earn 3 points. Yep. But you will be unable to solve questions 1 and 2. Oh, so you have to skip the next two, looks like. If instead question 0 is skipped and question 1 is solved, you will earn 4 points, but you will be unable to solve questions 2 and 3. You'll be unable to solve each of the next Brainpower. So the next 3 you can't solve, right? The maximum point can be earned by solving question 0, which is you get 3 points, and then you have to skip the next 2, and then you can get 2 more points right there. Oh, this is I forget what problem this is similar to, but it's like the like task scheduling type problem. Sorry, 1 second. My dog's going crazy. Oh yeah, anyways, this reminds me of those like, wait, is it task scheduling? No, this is like a greedy problem. This is like a greedy problem. Hmm. Or can this also be some sort of like memoization DP caching type problem? Those ones are always fun, maybe. Where we just have like a function that is cached, and it could be like max points given like maybe an index, right? And then we could just do is probably just return the max points starting at index 0. And we just trust that this will give us the maximum points you can earn if we started at the 0th index. Okay, let's try that. N is the length of the questions. We just want the question size so that we can have some sort of exit case, right? And our exit case would happen when our index is off of the array. So the exit case is when I is equal to n, or I is greater than or equal to, right? We could be a little bit more forgiving, more broad. If I is greater than or equal to n, return 0, because there's no points that you can get anymore. We're off the array. Okay, Otherwise, there's like two choices, right? The first choice is to solve the current question. And when we say current question, it's questions at I, right? I is where we currently are at. Solve the current question, or the other choice is to skip the current question, solve the next one, something like that. So if we solve the current question, what does that mean? Well, we are going to be getting that many points, right? So questions at I at 0, that's how many points we get. Plus max points at, and then what's this index right here? It means we need to skip the next two. Max points at I plus questions I1. I think this is what it means. So if we're at 0, the next thing we can do is 2, right? 0, 1, 2. No, we have to skip 2 and go to 3. So plus 1. Okay, so we just trust that max points starting at this 2, 5 will give us the max if we were to solve the current question. Now, if we were to skip this question, we can solve the direct next one, right? Skip is equal to max points, and we don't have to calculate this. That's why we will just call max points on I plus 1 and trust that this will give us the max points if we were at the index I plus 1. And then I think all we need to do, right, is just return the max of the two choices, return max of either solving the current one or skipping it. Let me submit this for now. Okay, that works, and then there we go. Yes, okay. Why? It says I got it, right? Okay, good. Yeah, that one definitely felt good. Just really quickly, like this caching thing, maybe we can be a little bit more explicit, which is super easy, right? How is it easy? Let me think. Um, we can do like a has cache is just false times n, and then we could have the actual cache, which originally has nothing, times n. Return 0, that's fine. If has cache at I, then we just return the cache at I. Otherwise, our result is the max of solve and skip. We can definitely return that result, but before that, let's add to our cache. So this is just doing our cache from scratch, which means we have to do has cache at I needs to be true, and then our cache at I needs to be the result. Okay, false is not defined. Yep, it has to be capitalized. And there we go. Maybe is this one faster? So that one was 26%. Just a little bit, but yeah. Felt good. There's always only two choices. Yeah, pretty classical problem. What's the so wait, so what's the time complexity? Um well, we're always going to visit things only once, right? So I believe it's linear, like O of n. And then has cache is O of n space as well. But yeah. But yeah, hope you guys enjoyed and see you tomorrow.